The following presentation will cover the 10% brain myth and provide evidence that disproves this myth. The 10% brain myth is a popular myth in biopsychology that humans only have access to 10% of their brain power and that the other 90% has yet to be unlocked. It is also thought that unlocking this other percentage would give you superpowers. However, this myth is erroneous. The 2014 movie Lucy was centered around the 10% brain myth. Lucy was instructed to transport a surgically implanted package of a new drug to another country, but then she got into a fight and the drug packaging broke, resulting in her body absorbing the drug. The drug let her reach maximum brain capacity and gave her intellectual superpowers. This myth was found in a blog post about the movie Lucy, but can also be found in many articles about neuroscience myths and in popular media. This myth is false because we are constantly using more than 10% of our brain to take in sensory information from our surroundings. The sensory info received goes to multiple areas of the brain as indicated by brain imaging studies to elicit certain functions. Not only have we been able to distinguish certain areas of the brain being associated with certain functions, but also the entire brain is active during most activities. It is likely that this myth developed from the misunderstanding that there are 10 times more glial cells in the brain than neurons. It could also have been developed into a well-known myth because it is an intriguing idea that it is possible for humans to access more brain power, thereby giving them superpowers. The brain is active during sleep as well as waking. Therefore, if the entire brain is active during sleep, we must have access to 100% of our brain power. Maggette's 1995 found sleep has a restorative effect for nervous tissue. The study used EEG to attempt to clarify what the restorative aspect of sleep is. Overall, a model of sleep function showed that NREM sleep is required to restore cerebral glycogen. The evidence showed that the restorative process described is happening independently in each piece of neural tissue, so the entire brain is working throughout the night. It is unlikely we only have access to 10% of our brain power because certain complex cognitive functions require multiple areas of the brain to be activated simultaneously. Sator et al.'s 2007 found playing music requires the processing of a lot of stimuli in order to allow for the intricate sensory motor activities that let music be played at the proper speed and pitch. While playing an instrument, the auditory and motor systems are interacting because each movement makes a sound and each sound stimulates another movement. The authors prove there is a coupling between the premotor cortex and the auditory cortex when playing an instrument, therefore providing evidence that multiple areas of the brain are working simultaneously. While we have determined that certain parts of the brain are responsible for certain functions, there are multiple areas activated during all functions to process the multiple forms of stimuli being received. Another example of this would be Gerald and Troy's 2002, proving that visual areas have a great importance in speech comprehension for individuals with cochlear implants and a control group of normal hearing. They studied the significance of reading mouth movements as a process of visual cortex interacting with the auditory cortex. Regional cerebral blood flow was monitored using PET scans while participants were given the stimuli of someone speaking. The PET scan showed which areas were activated when the auditory stimulus was provided. They concluded that there was processing of language in parts of the brain that are not classified as language areas, but rather visual areas in both cochlear implant users and the control group. This helps to prove the 10% theory is erroneous because not only did the PET scan show there are specific areas of the brain that are activated for certain processes, but it showed the importance of cross-modal interaction. Guznard and Reigel's 2001 found a baseline for PET and fMRI imaging techniques. This baseline does not mean that there is no activity occurring in the brain because the brain is consuming energy even when at rest. The baseline serves to be used for comparisons when a stimulus is introduced. The entire brain is active at a certain equilibrium, and functional imaging highlights the changes in this equilibrium when a stimulus is introduced. Therefore, the functional imaging techniques are highlighting what pertains to their studies. The areas shown in studies are not the only areas activated. Based on the evidence in the studies mentioned, the myth that we have access to 10% of our brain is not true. Brain imaging has not only allowed us to determine what different areas of the brain correspond to functionally, but also shown us that the brain is always active. Imaging techniques just focus in on the relevant information. Also, if we were to use only 10% of our brain's capacity, we would not be able to perform intricate cognitive functions like playing a piece of music. The amount of sensory info entering the brain would require 100% of brain power to sort through and process for humans to function successfully. Also, the restorative properties of sleep provide evidence that we use 100% of our brain power while we restore cerebral glycogen during REM sleep. The 10% myth is erroneous. While it would be nice to imagine superpowers stemming from unlocking your full potential, that is not the case. Humans use more than 10% of their brain power. We use 100%. The following sources were utilized to create this presentation.